Now let us look at this problem as an can we define or can we implement something like call an one pass assembler. So you can say that hey, in the two pass assembler we are actually going and parsing, at least looking at the each of the instruction twice, right? One is the pass one or step one when we are actually determining and populating the symbol table, and pass two where we are actually generating the object code. Can I do it in one shot? So one thing you need to understand why we need to have the symbol table generated as a pass one or step one, because of the forward referencing. Remember the concept we just discussed as a forward referencing couple of slides back. So if it is not a forward reference, then we are okay. Let's say a program doesn't have any forward reference, then what would happen? Like let's say we are generating machine code for this instruction, first instruction, second instruction, third instruction, fourth instruction, fifth instruction, sixth instruction, and so on and so forth, right? So unless a instruction is referring to a label, we don't need to consult with the label address and all this stuff. We can just generate this machine code, right? And even then, like let's say we are somehow we can generate all the machine code and come here, like the very last statement, which is referring to the loop. Now, at this point, I know where is the loop is because I have already encountered in my sixth statement the definition of loop. So when it is being referred, I know its address. Okay. So in that situation, there is no point in making like two pass assembling, right? It is just one pass assembling. You generate code, and you note down, okay, I got a loop, then generate machine code, and then whenever the loop is referred, we know already the value of the loop, and we can generate the machine code for that. No need for two pass, right? For in that situation, it is that only the forward referencing that is a problematic thing to making a one pass assembler. Okay, only forward referencing. For example, let's say we are happily doing for one pass assembler, we are doing machine code generation with all this instruction till we hit this BNE R8 R9 L1. Now see, till now we have not encountered a label name L1, so I don't know, right? I cannot resolve the address of that L1. Okay, so then that's the problem. So that problem is solved by your two pass assembler. First pass, we just gather all the labels and determine its address value, and second pass, then we can refer to at this point BNE R8 R9 L1. I can refer to that symbol table generated at pass 1 to take up this address and generate the machine code for this specific example, right? Specific statement. So now in the one pass assembler, what we can do, when we encounter a forward reference, one strategy can be that we defer this generation of the machine code of this instruction and just take a note that hey, instruction number this is like what instruction number 1 2 3 4 5 6 7 8 9 10. Instruction number 10 we have not converted into machine code because we don't know what the label value is. Okay, label address is, right? We kind of defer generation of machine code at this point and move on, right? Move on, and as soon as we encountered the label, we go back, hey, I have now definition of L1. So what are the instruction that was referring to? Like for my case, instruction 10 was referring to this label. So let's go back and patch up that and regenerate the code for this instruction 10, which is using the L1 as a forward reference. Okay, that is the strategy. Now, another thing you need to understand, when this object code is generated, this object code is written into the disk, right? So disk writing is a sequential affair. Like when you cannot just do randomly write into the disk, it has to be sequential opcode for first instruction, then second instruction, then third instruction, then fourth instruction, then fifth instruction. Then what happens at this point? I cannot generate the code, machine code at this point, so that means I cannot write it back into the disk at instruction 10. That means it is kind of holding, it will kind of hold till this L1 is resolved or being defined at this instruction, right? This L1 label, the instruction labeled with the L1. So that means a one pass assembler, it is problematic to generate the code and write back into the disk, because disk is a sequential writer. So we need to write on the disk sequentially. What we can do in this case, that we can, instead of writing it into the into the disk, we can still generate and store it in the memory, in the primary memory. And you know, the primary memory writing is not a sequential. You can go and change certain content of certain memory piece at any point of time randomly, right? It is a random access memory, RAM. So instead of writing the object code directly onto the disk in this one pass assembler, what we need to do is store the generated code, machine code, object code in the memory till every one of the instruction in that code has been converted to the machine code. Okay, so now if we are now assume that we are holding the machine code in the memory, in the primary memory, then it is easier. Now as soon as the L1 is defined, I can go back to the memory position of that instruction BNE R8 R9 L1 and patch up that part of code with generation of a new machine code at that point to really translate this specific instruction. Okay, so we can solve the problem. So by holding everything onto the memory till we are done with the entire code conversion, and once we are done, then the whole memory with all the machine codes be written back into the disk. All right. Of course, then it pauses. It actually pause. It has this problem of holding the entire object code in the memory. That means if your assembly code is really big, you are looking for a higher memory consumption from your assembler. Okay. And also there is another challenge associated with this, which is not relevant to the MIPS, the processor we are going to study in this class. For the MIPS, every instruction is machine code is 32-bit. So we exactly know where that instruction 10 lies in the memory, where the because everything is 32-bit uniformly. So we can calculate the location of the 10th instruction, which is using the forward reference of L1, very easily. Now other processors, other class of processor, there are a lot of different examples of processor which does not use same length instruction. Means like all the instruction are not of same length. For MIPS, it is every instruction is of length 32-bit. For other processor, it varies from instruction to instruction. Maybe some instruction is like 48-bit long, some instruction is 24-bit long, some instruction is 16-bit long. In that case, you need to actually start adding up all the addresses and it's the instruction lengths to come up with and determine what is my instruction 10th instructions machine address B, right? So that poses additional that actually impose an additional challenge to that memory determination and code determination as well, but not relevant to this class. Okay, just I want to make sure that you are aware of this fact as well. in the one pass assembler, apart from to need to hold the entire object code inside memory, which will increase the memory footprint of the assembler at the runtime. It may impose challenges for machine with a variable length format. Okay, so but people does make one pass assembler, where especially if your code assembly need to be done on real time, like it's like some part of the program is generating some code which need to be like assembled on fly and attach itself back to the main process. In those cases, one pass assembler makes sense. So point is that in general, your assembler is two pass, where first pass is generate the symbol table, second part it's generate the object code and which directly write into the disk. There is possibility of one pass assembler as well, where it has a pros and cons. It's definitely is faster because we're talking about just one pass through the code, and we can generate the object code through one pass, but it needs more memory and there can be more challenges if we have the variable length format. Okay.